In this tour, we're going to be building a sample system using design mode. This tutorial is part of the brief new feature tour of QSControl.net version 3.0. You'll find this same tutorial spelled out for you in the QSControl help file. I can show you specifically where you'll see it. You can get to the help file directly from the QSControl.net folder of your program folders here. And right there's the help file. And if you launch the help file, right under the Getting Started chapter, there's a topic called Brief New Feature Tour of QSControl.net version 3.0. This is what I'll be doing today. I'll break this up actually into about 4 different tutorials. So this first tutorial is basically going to be building a sample system and setting up the basic system design. So we'll launch Venue Manager. I've already launched it on my computer. You've done that already. You already know that from the earlier tutorials. And in my design environment, as we talked about earlier, the first thing is that you're going to notice is make sure you are in design mode as opposed to live mode. By default, if you've never run the program before, you are likely in a generic venue file called Venue1. We recommend that for every project that you do, you create a new venue file. So we're going to make a brand new one right now, and I'm going to call it My New Project. And now, indeed, I have a design inventory specifically for my new project, whatever that project might be. Obviously, you're not going to name it something generic like My New Project. You'll call it First Baptist Church, or you'll call it Municipal Concert Hall, or whatever's appropriate for a particular project. At this point, you're going to start adding devices to the inventory. 2 ways to do this. For this design, I'm going to be using a 922AZ and a 922UZ for the tutorial. Obviously your devices might vary, but the process is going to be exactly the same. If you double click on the word design inventory, by default it'll take you back to that same inventory wizard that we talked about before in earlier tutorials. In this case, you could discover and map connected devices. We're going to do that a little bit later. But let's say you were actually connected to a network with equipment, then in fact you would click this button, which would launch a Discover and Map Devices window. You would then start searching the network, and it would find devices physically connected to your network with their own IP addresses, and you would be able to add them to or map them to your design. We're not going to do that right now. We're just going to start right from a design that does not have any equipment attached. I'm going to pretend that you're in your office or on an airplane or in your hotel room, and you're not actually physically connected to the same network as the gear. So we're going to be designing in a, quote, offline mode. So the first device I'm going to go ahead and add using the toolbox here to grab a 922AZ, drag it, as the window says to drag it, to my design inventory. You have to actually drop it on the word design inventory. You can't drop it here, it doesn't allow you to. But drop it right on the word design inventory. A window is going to come up and allow you to add that device to the inventory. We're going to give it a name. And again, give it an appropriate name for your system. Don't just call it basis number 1, basis number 2, basis number 3, and so on. That's not very descriptive. Why not describe it by either its function in the system or its location, like rack number 1, rack number 2, so on like that, or balcony rack, or main PA rack, or something appropriate like that. I'm just going to call this one, because I have 2 bases actually on site at my facility. This one's going to be in the left rack, and the next basis I add is going to be in the right rack. You do not have to add the password and the IP address at this time in design mode. You will have the opportunity to do that when you connect up and discover the real devices that are on your network, and then let the system tell you what's available. You could also add notes into this column here, and I'm just going to type some text in there. It doesn't matter what you type. Those notes will be part of the basis. They'll be part of the design of the inventory system. So you could write date information in there. You could write design information, pending design information, anything appropriate to you for your system that will help you remember pertinent information about this particular design. So I'm just going to delete that gibberish there. So we'll say OK. Now it's going to add that device to my system. Notice it has the name that I gave it, and it says unmapped, because it means that I have not specifically mapped that particular item to a real-world device yet. So we're working in purely design mode at this point. Also, just to give me a little bit more room on the screen, I'm going to close out the event log. I don't need the event log at this time, and I don't really need to see this design rule check window, because I can always bring that up by clicking on DRC details, or design rule check details. That's what that stands for. So if I click on the design rule check, I get it back. So I don't need to see it. I can get to it very easily. The archive folder that we discussed in earlier tutorials, I don't need to see that at this time. I can either close it or hide it. I think for this purposes, I'll just hide it off to the side, let it slide away. We'll be coming back and visiting that window, not so much for archives, but for the global presets and for the masters a little bit later in other tutorials. So I've opened up my window design area quite a bit here to give me more room, because I'm going to need it here in a moment. In this system that I'm designing for, here's my basis. If I click the little plus sign, I see that there are some configs underneath it, and clicking that plus sign gives me 8 possible configs. And if you remember, configs are like wiring diagrams. So double clicking on any one of these will let me start designing that wiring diagram. There's already a certain amount of layout given to you or presented to you already. You're free to go in and then modify this layout and add more functionality to it. That's what we're going to be doing. So we've got our first device in there, the left rack. Let's go ahead and add the second device. Now, I can go back to the inventory tab and drag it again, or a shortcut to do that is just to right-click on the word design inventory and say add device, and it brings up the same add device window. However, this time I have to specifically tell it which device I'm adding. In this case, I'm going to be adding a 922UZ, and this one's going to be appropriately enough for my system. This is going to be the right rack. And again, I don't need the password or the IP address. So we'll go ahead and add this one to the system, and there it's added a second device, and it has its own collection of configs. Now, I think you'll notice something interesting here. The configs for the first rack are just generically labeled config 1 through config 8, as exactly the same name for the configs in the right rack. So what that means is if I look at the first config and then go look at the other config from the other rack, it brings up a second tab, but now they're virtually identical. The only difference really is the fact that this config right here has analog inputs, and those analog inputs with their block look thusly. Notice it's opened up a new tab for me. These are the line inputs for a basis 922AZ. However, this config 1, which is this other tab, has slightly different inputs. It has what are called universal inputs, and those look a little different. Well, if you're following along with the program here, you'll notice that all these tabs start to say config 1, but they're different config 1s. How do I know which is which? A better way is to label the actual configs by what those designs are going to hold. So this config, I'm going to right-click it, and I'm going to go to Properties and change its name, not config 1. Let's call it, let's see, this particular config that I'm using is going to have the CD player in it. So I'm going to call this CD config, or just CD is good enough. I'll know that that particular config is, source, there we go. CD source. So that config is going to have the CD source in it. This config, and notice that when I renamed that, any tabs that were associated with that now carry that exact same name as well. And so this other config, I'll go ahead and rename this one, and this is going to be the right side of the room, basically just for the right amps and the right part of my system. So I'm going to call this the slave config, or just slave audio. Just slave is good enough. You're free to go back and rename these any way you want to. So now I have a config that I can readily see in the tab. This is the source, this is the slave, this is the input for the CD sources coming in. I haven't labeled those yet. We'll get to those in a moment. And here's the slave input, and so on, if it's appropriate. I am free to close any one of these windows or groups of windows. I can also drag tabs around if I want to rearrange how the different order of the tabs are on my screen. Very useful interface here, this multiple document interface in the MDI tabbed mode. I don't really need to see this inventory anymore. I'll go ahead and close that out. So, in fact, let's close all the windows and just start with new fresh windows. So there, I closed everything. So let's start with the CD source here. And as I mentioned earlier, this is the one that's going to have my CD player in it, and I actually have it wired, or intend to have it wired, to inputs 1 and 2 of this particular basis unit. So I might as well label these wires. CD left, that's the left input. Notice that it continues the name on the other side of the wire once you hit the enter key. CD right. And in this particular basis unit, the outputs which go to my data ports, channel 1 and channel 2 happen to be a pair of speakers, with channel 1 being the far left speaker of my system, and channel 2 being the far right, the center left speaker. I've hit a problem here. The problem is I've run out of character spaces. You're limited to 16 characters for most text labels. So you want to be descriptive, but you also might have to abbreviate a little bit. So let's change this name, shall we? Let's abbreviate the word center to just CTR. And actually the word speaker, SPKR is good. And I'll do the same thing for the other one, just to be consistent. Now, that's just because I'm going to label what those outputs are driving. Those outputs will be driving an amplifier that's driving my far left and my center left speaker. Certainly, you could label it by the amplifier location, by the amplifier name. You could label it by zone. You could label it anything you want to label it. Just label it. Don't go with the default generic labels that are already there. Channel 3 input, channel 4 input, port B, channel 3 port. Because those generic labels don't mean anything as far as your system is concerned. You're not going to remember tomorrow what channel 1 input is, or channel 2 input, or if you come back a month from now. You'll have to look at some drawings and try to recall exactly which input was doing what. But if you labeled things exactly by their name or their function, then it's very clear what's going on with your system. We haven't gotten to it yet, but we're going to be adding CobraNet to this system too, and I just happen to know that I'm going to be driving the CD player audio not only to the local speakers that are connected to the amplifiers on this first data port, but I also want to use these outputs to drive a CobraNet bundle for the second rack, in this case the right rack. So once I've wired them, I'm allowed to label those, and that's going to be called, let's call it left music and right music. Okay, so all I'm really doing is just kind of setting up some wiring ahead of time. Speaking of CobraNet, let's go ahead and create this CobraNet bundle. And this is all explained in the help file, but to utilize CobraNet, you have to tell it which channels you want to use by turning them not off, but instead giving them a resolution of audio output. The default CobraNet resolution is 20-bit at 5 1/3 milliseconds. However, our design that we're working on, we've set up all configs to start out as 2 2/3, not 5 1/3 millisecond. So I'll just let it go at 2 2/3. And maybe I want this one at 16-bit, maybe I want this at 24-bit. You're free to mix and match the resolution. Obviously, my CD player, being a commercial CD player, is 16-bit. So I'm not going to gain anything by going anything above 16-bit. I'm not going to make the audio sound better. So 16-bit resolution for both of the channels is fine. As far as bundles go, I haven't defined any bundles. So I'm going to have to make a bundle first to carry that audio over to the other rack. So we're going to add a new bundle. I'm going to call this music, because that's what it's going to carry. Again, you want to define your bundle names by probably what they carry. I could have named it, I could have called the bundle 4 right rack. I could have labeled it like that. That would have been fine too. Anything that just mnemonically helps you remember what that audio is, it's going to be going into that bundle. Again, I prefer telling it or labeling it by what it carries. And again, you could write some notes. You know, this bundle has only 2 channels, the left and right CD audio signals. Something like that. And then for bundle ID, we need to put a number between 1 and 65,279 that are allowed for CobraNet bundles. Again, if you read in the help file, you'll find out more about bundle assignments. I'm just going to arbitrarily pick a number 1,000. So I want bundle 1,000 to be used. It's going to be named music, and I've created that bundle. So now that is the specific bundle. I could potentially have a list of lots of bundles, but I'm going to specifically use this bundle, bundle 1,000, that I've named music, to carry these 2 channels of audio that have been labeled left and right music, and those were labeled purely because we labeled the wires here when we wired it in. That's where those labels came in. Also, if I double click this side of the DSP block, I bring up all of the outputs that are outputs 9 through 24. The first 8 outputs, of course, go to my data ports, but the remaining 16 outputs are for CobraNet only. And by default, all outputs are muted and fully attenuated. And for these CobraNet drive signals, I'm going to make sure that they are unmuted and 0 dB or unity gain. For most CobraNet signals, that's what you want. For the data port outputs, those are also by default muted and fully attenuated. However, you might choose to wait until you're actually connected to the gear before you unmute these and change the levels, because you don't really know what level the amplifier is set for, and you don't want to take a chance of damaging some equipment or hurting people's ears by coming up with some arbitrary level. So we'll do that. We'll do that in live mode. So back here on the actual config file itself that I've called source, here is the layout so far. And just like I set the output level and the mute state of these outputs, I have to do the same thing on my analog inputs. I have to set up what I expect. Now I can do this in live mode, but I already know that this particular CD player I'm using as an input puts out a very, very hot signal. So I'm going to preset ahead of time what the input sensitivity, making it the least sensitive setting. 1.5 volts RMS is the most sensitive setting. 18 volts is the least sensitive setting, but that's compatible with most pro audio gear, mixing consoles, and so on that put out very, very hot signals. So we'll go with that. You have no choice of resolution. That's our A to D converter's resolution at this stage. And the activity LEDs will flicker and glow with audio signal as the audio is playing live. Okay, so back here on my design, I'm now going to drill into the DSP and start to lay out my signal flow. Notice that if I kind of zoom in so you can see it a little bit better, These input blocks are already labeled, and the reason they're labeled is because I labeled the wires here. Also, double-clicking a block shows me that I've already preset the value to 18 volts RMS of the 4 choices that were there. If I had changed my mind and said, no, I want that to be 3 volts, that's the same thing as adjusting it at this stage. And there you can see, indeed, it's gone to 3 volts. I may say, no, you know what, I really do want that to be 18 volts. And if we go back to the DSP design, sure enough, it has reverted back to the 18 volts. So there's 2 different ways to change that level. On the output side, scrolling across, these are labeled for the same reason. I labeled my output wires, so therefore these nodes are labeled, as are these nodes because I've wired them to the Cobra net. And the fact that they're wired to a Cobra net bundle turns these little flags green. That's what those green flags mean. If I wire a new line, let's say I wanted to wire Cobra net output 3 to a bundle. So if I look at my design and take, say, output 3 and wire it to some signal, then sure enough, we will now see that output number 3 does indeed flag me as showing that's going to be a live Cobra net feed at some point. But I don't really need that, so I'm just going to delete that line. Alright, now, therefore in the design, let me do a zoom to fit so we can see everything. There's my DSP block with the 24 inputs on the left, 24 outputs on the right, and I don't have the any wiring in between. I don't have a configuration created. We're going to do that right now. So the first thing I know I'm going to add is I'm going to add a gain block. We're just going to do a real simple design. We'll do a 2-channel gain block, drop it right in the middle of the screen. I'll wire these 2 inputs directly to the gain block. Notice that because the nodes were labeled, the wires carry through the same label names. I'm not forced to keep those wire names. I might decide to call this, no, you know what, I'm just going to call this background music left, and I'm going to call this one background music right. I am free to certainly relabel those wires if I want to. The block itself should also be labeled. A generic name such as block 49 doesn't mean a thing to us. You won't remember tomorrow what block 49 is versus block 22 versus block 51. But if you label it, okay, this is the CD gain or levels, then I know exactly what that signal is going to carry. And I'll take the output, and this time rather than do each individual line one at a time, I'm just going to draw a rectangle around both, enclosing both of those nodes, and then it will allow me to grab them as a pair, and it will drag them in that direction. Now, the output nodes of this were not already labeled. If you want to see that again, I'll delete them to show you. Because they are not labeled, and they can't be labeled until they're wired, then it'll come up with a generic wire name, signal 3 and signal 4, because it's the 3rd and 4th signals we've drawn on the screen. But again, I can relabel these, and I'm just going to continue the same naming scheme. Background music left, background music right, and lo and behold, there's my signals. Now, we decided that for this config, the 2 speakers that I'm going to be wiring up to are the far left speaker and the center left speaker. The other rack that I have in my system, the right rack, is going to be carrying the center right and the far right speaker. We haven't worked on that design yet. I'll do that in a moment. So this doesn't make sense for me in this particular design to have my right audio going to the center left speaker. I want that to go across the room to the other side of the room. So I'm going to delete this line. I'm going to send another left channel. So there's my far left and center left speaker. And if I wanted to put other DSP functions, delays, EQs, filters, and such, I could put them in line with those outputs there. In this case, I'm going to take the right output, and that's going to actually go to both sides of this. So I probably should relabel this output. That's background music right. And I really should label these because it's really not left music and right music anymore. They're both carrying background music, and we can relabel those. So if I come over here and relabel this. I'm just going to call this right feed. And I'm actually going to delete this line. I don't even need this line. So it's going to really only carry one signal on it. Therefore, I don't need this anymore either. It's a nice thing about design mode. I'm free to try out different things and do things different ways. So back in my design, I no longer have a live Cobranet feed. I don't even need this wire anymore. So really, all I'm doing is taking my background music output, and that's what's going to feed the right side of the room and the right equipment rack. So we'll deal with that way. So there's my signals right there and what I'm going to drive. Let's zoom to fit. There's the overall design, but I have a lot of inputs and outputs I'm not even using. I can hide those. So I right click on the background, the grid area, and I say hide unused blocks. And now I've taken away all the stuff that's unnecessary for this design. I can move these around either individually or as a group, whatever makes sense to my system. Let me go to the other config, which is the slave config. And you'll notice I keep adding tabs as I go along. Some of these, and eventually I'll just have this whole thing filled up with tabs. Just for cleanliness sake, I'm going to close out all my tabs and double click that config again so I bring up just that config. In this config, we're not going to use any of the analog inputs. We're going to be relying only on a Cobranet feed to come in. So that Cobranet signal coming in is that music feed. And we know, because of my previous design, that I'm only going to be sending one channel in that bundle, and it happens to be the first channel coming in. So when I wire that up, that first channel coming in from that receiving bundle, I can label that right background music, or right, I can label it anything I want to. We're just saying when that comes in, I'm going to call it right background music. It'll come in at a certain resolution, a certain sampling rate, and a certain latency. That's already set up for me. I don't, receiving bundles do not establish that. So there's my input coming into this particular config, labeled. My output, in this case, the data port outputs that I'm going to be using. The channel 1 happens to be the center right speaker. And again, I've got the same labeling constraints as far as 16 characters, so I'm just abbreviating it. And this is going to be the far right speaker. And if we look inside this particular basis, now I've got that input node and I've got these two output nodes labeled. And really, for this example, all I really want to do is take that Cobranet feed and feed it directly to these outputs. And that's what's going to feed that side of the room. I'm done with this config. So right now I have set up all of the design for my expectations. What I'm going to add to this is some snapshot capability. And I'm going to make a simple snapshot which will talk to this particular gain block. Let's do that first. The way we do snapshots is to select a parameter or a group of parameters and store its current state of settings as a snapshot. If you want to think of this as a preset, you can, but we use the term snapshot because preset could mean something else, and you'll see in a moment what we're talking about. So the first thing you do when making snapshots is to always start with nothing marked. What that means is nothing is already marked to be stored as a snapshot. You don't know if there's other items in this particular config that could be marked until you open them up and look at them. Now I'm going to pick that gain slider and that gain slider's current value. Notice that even though I clicked on the gain slider with my little snapshot tool here, the icon that looks like a arrow with a camera, and I right click to get rid of it. When I clicked on the slider, the little box, little text box, is actually what got marked in the lower left corner. That's on purpose because that means whether I use the slider to affect that value or I type in a number to affect that value, the end result is whatever that text value is the gain value that I'm interested in storing as a permanent value. So let's store this as a snapshot, and I'm going to use this tool here, which is store all the mark controls as a snapshot. I could have also gone to the snapshot menu, store mark controls as a snapshot, or I could right click on the background, going to snapshot, and store marked controls as a snapshot. Either way, brings up the exact same window, and in the state that they're in right now, I'm just going to call that full volume, or full up. How about full up? Keep it short. You're not limited to 16 characters here, however, the shorter the better, because the same title that you label that snapshot is what's going to appear on the LCD display of the front of the basis. You can recall these snapshots by using the LCD display without having the computer. So keeping those names short will make it sure it's readable on the LCD display. Let's take the levels down 10 dB for both channels, shall we? And I'm going to store that as a snapshot as well. This time I'll use that tool. And I'll just call this minus 10 dB. And we'll do another one. Take them down another 10 dB. Oops. There we go. Notice that as I type in a number for a parameter, the number is in red, and it actually does not affect the object until I hit the enter key. If I don't hit the enter key, if I click somewhere else, then the original value stays there and the object is not acted upon. I must hit the enter key, and then we see the slider drop down. So that's very important. You have to have that concept in your mind. So there's my third value, third setting right now, and that's going to be my third snapshot of minus 20. Okay. So there's my three levels that I've established. We can use this little drop-down tool to check and verify. Let's go to minus 10, and sure enough, the sliders jump to the minus 10 setting, full up, back to minus 20. Now, just because they're marked, and that happens to be the last snapshot I recalled, always down here in the lower left, Venue Manager will display for you the last snapshot you recalled. Even if I go in and mess these all up, that doesn't mean that I've edited the minus 20 setting. All it means is I've changed these parameters. However, the last snapshot that got recalled and stored was minus 20. So if I recall that again, minus 20, indeed, it reverts back to whatever the last stored settings for that snapshot. Now, certainly, I can edit this and restore those new values as either a new snapshot or copy it to an old snapshot. So if I say store, I either could store it with a new name or say, no, I want to use those new values as this snapshot setting. But I'm not going to do that in this example. All right, so we've got our snapshots set up for us, and I think they'll work just fine. Now, you can have multiple snapshots in a basis device. In fact, you could have dozens and dozens of snapshots stored inside of a config file. And you could have snapshots stored in multiple basis units, multiple configs, that are all recalled globally at one time, and we call those global presets. So let's see how those would work. Let's go to the data port outputs, which would be the panel like this, and I'm going to make a snapshot that turns the amp on and off for all four amplifiers. Let's just make a simple snapshot first that does it. You have to do the snapshot first. So I'm going to use my tool and select each one of these power control buttons for the amplifier. And then I'll right click to get rid of the cursor, for the snapshot cursor. And I'll store those settings. Oh, I forgot to do an important thing. Unmark entire config. Why do I want to do that? Because if you go look at the design of that, it's still got these marked here, and I don't want these to be included. Now, one way I could make sure that they're not included is to just deselect them again. Click on them again. It just toggles the whether it's marked or not, or just unmark the entire config. Everything gets unmarked, and then I'll just have to go back and mark these again. That's okay. It's just a small. Whenever you create a new snapshot from a new set of objects, it's always good to unmark the entire config when you're starting out. Okay, so now I have those 4, and only those 4 items are selected. Storing this setting right now as a snapshot. This is going to be amps on, and actually it's left amps on, isn't it? And if I pop these buttons out, that's standby, or for all practical purposes off, for the way the end user would think. So I'm just going to call that left amps off. Alright. And sure enough, just like we did before, we can check and verify in design mode that those snapshots do work exactly the way we expect it to. Amps on, the buttons all pop in, they turn green. Amps off. Now, we won't see the LEDs change color here because we're not connected to live equipment. That's a response coming back from that particular amplifier data port. Let me do the same thing for the other config, and I'm going to go to the data port section there, and sure enough I'm going to make snapshots, but first I have to unmark this entire config. Then I'll mark those buttons, right click to get rid of my arrow, and let's store mark configs. And notice, because I'm in a new config, I don't have any snapshots stored in there, so we're only going to put these 2 snapshots in here. And this is going to be amps on. Rather than call it right amps, I'm just going to call it amps on. You'll see why in a moment. And let me pop these back out so we have our amps off condition, storing that as a snapshot. Okay, and since those are the only 2 snapshots, I can test those very easily. So we know that those are going to work like we expect them to. Now we're going to make a global preset that will affect both racks. And to do that, I'm going to actually put, so we can see what's going on, I'm going to make a new tab group, horizontal tab group out of this, and that pushed that one down into there. So now I can look at both sets of panels. See, I've got the top row with my left rack, and the bottom row I have just this one tab. And I can move. I don't have to keep, if I want to take this DSP, I can drag this and put it down into this window, and here I've added it now to this bottom thing. But this is a real great way to look at two different windows at the same time. Now, let's make some global presets. And I'm going to save global presets for a different tutorial. But the global presets will essentially talk to both sets of snapshots. So basically I have my design, I have my snapshots created, and at this point refer to the global presets and the masters also. We're going to make some masters in the global presets and masters tutorials that'll follow this.